The next thing we're going to look at actually ties back really nicely into some of the things that we did with coordinate geometry, where we looked at straight lines and the distances between 2 points, okay? What I've got written here is the word magnitude of a vector. And we said that the magnitude of the vector is the length of the line, or how long the vector actually is. And I've written in this blue box that the magnitude, and it's got these 2 lines around the vector A, the magnitude A of a vector A is its length. So if you ever see these 2 lines here, these 2 long lines written either side of it mean the magnitude of that particular vector. And I'm going to try and find out here, for the vector AB, which is 3, 4, we're going to try and find out the magnitude of the vector AB. Let's just try and remind ourselves of what that's actually asking for us to do. It's asking for us to find out the length of the line AB. That's what it's actually asking for us to find out. And you can see that we've got a triangle that's drawn here, which is right angled. And we did something similar when we were looking at the distances between 2 points. We have to use what? Pythagoras. Okay, so if we wanted to find out the length of this line AB, all we need to do is Pythagoras to this triangle here. So the length of AB would be the square root of 3 squared plus 4 squared. It's just Pythagoras. There's nothing new here at all. And that just gives you what, Shahan? That's 5, because that's one of the famous Pythagorean triples, just 3, 4, 5. So you can see here, as the notes have said, if A is 2 parts, so you've got an x part and a y part, to find the modulus of A, you just square the x component, square the y component, and square root them. It's just Pythagoras, okay? It's really similar to what we looked about, the distance between 2 points that we've got here. So I'll just do these 2 that I've got here, and then you guys can try these ones here. So I've got something that's going 1 to the right and 1 down. The magnitude of that vector, either side of it, would just be 1 squared plus 1 squared, which is root 2. Why did I not do plus minus 1 squared? Minus 1 squared is the same as 1 squared, and it's just easier just to take the positive values of those things, just like we did when we were doing it with the distance between 2 points. You'll find you'll make less mistakes if you ignore the negatives that you have with these things. So if I was going to find the magnitude of this one, it would just be 5 squared plus 12 squared. Anyone know what that is? 13. You should know that one. 5, 12, 13. So the magnitude of that is 13. I'm just going to give you 30 seconds to do these 2 magnitudes that you've got down here. Okay, Faisal, what have you got as the magnitude of A? Can you just take me through the first stage as well? Yep, which is root 16 plus 1, which is root 17. Okay, so we can just leave that as the square root of 17. Charmaine, did you get onto this one down here? What's the magnitude of this? Which is just 2. How could I have worked out that the magnitude of this one was 2 without even doing Pythagoras? Because it's a flat line. It's just going 2 to the right, and it's not moving up and down. So although I don't mind you using that method there, sometimes it's better to think to yourself before you do the question. I kind of can just tell what the magnitude is because it's just telling me it's going 2 units to the right, nothing up and down. So vectors is this weird kind of topic. There's like loads of tiny, tiny little things that we need to learn about, and then we'll do a big chunk of practice after this bit, okay? So magnitude of a vector, very similar to what we've looked at before. We're going to now extend this a bit further to the idea of a unit vector. And it says a unit vector is a vector whose magnitude is 1. Let's just break down what that's saying there. We've talked about this before, but it's a vector whose magnitude is 1, whose length is 1. So we're describing how something is moving, and we want it to be a unit vector, which means that it has a magnitude of 1. It says that there are certain operations on vectors that require the vectors to be unit vectors. We just scale the vector so that its magnitude is now 1. Unit vectors pop up in more things if you're going to be doing like engineering at university. So it's just something that they add in at this kind of stage, okay? We've got this vector here, and our vector A is 3 to the right and 4 up. So what is our magnitude of A? 5, yeah. It's the square root of 3 squared plus 4 squared, which we know is 5. Now, I don't want it to be 5 units long. I only want it to be 1 unit long. So I'm going to just guesstimate and say that's about how far along that I want it to be, okay? So all I need to do to be able to find out the unit vector of A is I want it to look like this. I want it to be in the same direction as this, but I don't want it to be 5 long, I want it to be 1 long. So I'm going to multiply it by a fifth or divide it by 5. Same idea that we've said was really important. Vectors are parallel if they are multiples of each other. It has to still be in the same direction, so I'm going to fifth it, divide it by 5. You could leave it like this, or you could write it like this. You can clearly see here that this vector, 3/5, 4/5, is definitely in the same direction. If you did Pythagoras to 3/5 and 4/5, what would you get as your result? 1. Why do you get 1? Yeah, because it's 1. And also we've just said that the definition of this thing here is that it has a length 1. So I've written how we find a unit vector. If A is a vector, then the unit vector, A with this little hat on the top of it, in the same direction is A, the vector A, divided by its modulus. It's kind of a bit harder to see that, but we're doing 1 divided by 5 times by the vector A. So you may like to see that as 1 divided by the modulus multiplied by the vector. You may prefer to see it like that. I would always leave this as surds and fractions. Okay? Don't do decimals for these questions, because this one's going to need a decimal. Don't do it as a decimal. So you've got 2 of them here that I want you to have a quick go at using this. I know this is a very choppy lesson, but you've got to find those 2 unit vectors, the unit vector A and the unit vector B. Yep. These lines mean find the magnitude of the vector. They mean to do like Pythagoras to it. So like here, this one, why this one's written down? Okay. So this would be the square root of 4 squared plus 1 squared, and it means the magnitude of it. It means the length of it. Okay. So for this one, to find out, we found out the magnitude of the vector first by saying it was 5, and then we divided it by 5 so that we got it as a unit vector, that it just had a length of 1. So you need to find the length of this one first by doing the magnitude of it, by doing Pythagoras. If you have finished those 2, which I'm sure you have done, you can start reading the last bit before we do practice today, which is about the direction of vectors. You can start reading that and think about how you might answer it. I'm just going to take maybe 30 seconds more just to give people the chance to finish both of those ones off. Yeah. Yeah. Not if you find the magnitude of that, it won't be 1, because you'll do 1 squared plus 1 squared square rooted. That won't give you the answer 1. Okay, so let's have a quick look. First thing we need to do is we need to find the modulus of A. We need to find out how long the vector actually is. Ishak, what did you get when you found the modulus of this? Yep. Which is 13. So the unit vector will be the 12 and the minus 5. But what did you have to multiply it by? By 1 over 13. You can either leave it as this, or you can write it as 12 over 13 minus 5 over 13. Note that if you did Pythagoras to this, if you found the magnitude of this, you better get 1, because if you haven't got 1, something's gone wrong, okay? Red one, what did you get as the magnitude of B? Root 2. 1 squared plus 1 squared, which is root 2. So the unit vector for B is what, red one? 1 over root 2 times 1, 1, which is the same as 1 over root 2, 1 over root 2. Okay? Last bit of directions of vectors before we can then just do some practice. I know there's been a lot of me talking with you guys today, but I don't know how else to get all these tiny, tiny little topics in. Last thing we're going to think about is the angles, okay? So we look at directions of vectors, and the first thing that we're being asked about here is we want to find, boys, what's the problem? We're going to look at directions of vectors, and they're always quite specific about how they want you to find the direction. This one, it says, find the angle between A and the positive x-axis, right? This one, you definitely need to start off by doing a sketch of the vector. You've got to do a sketch of these ones to try and think about where the angles are actually going to be. This means that the vector x is moving 4 along and it's moving 5 upwards. So this is our vector A that we have over here. It's moving 4 along and it's moving 5 up. That's coming from those instructions that we've got there. And it wants us to find out the angle it makes with the positive x-axis. Well, the positive x-axis, we know, runs along like that, doesn't it? So the angle that it's actually asking for us to find is this angle here. And I want you to think to yourself, I don't want you to say anything out loud, what area of maths does this remind you of from GCSE? Amina, what kind of area of maths do you think that reminds you of? Trigonometry, SOHCAHTOA, okay? This should remind you of SOHCAHTOA. The previous slides have been about Pythagoras. Surprise, surprise, SOHCAHTOA is also here as well. Which bit am I going to use out of SOHCAHTOA? TOA, because I've got the opposite and I've got the adjacent. So we're going to use TOA, which says that tan of my angle is the opposite over the adjacent. So you find out theta by doing what operation? Tan minus 1, the inverse tan of 5 over 4. Okay? No, we'll be in degrees for this topic because we haven't technically done radians yet. You've looked at it in further maths. Pardon? A theta. Okay, this letter is theta. I will come and have a look at it in a second. It should be 51.3. Because you're in radians mode. So to get out of radians mode, you go shift setup and then down to angle. Okay. Did you find it, Ishraq? Shift then setup. Angle unit should be degrees. Just for this bit, it'll be degrees, okay? Okay, guys, final bit for me to speak to you about. Again, this one is going to need a sketch, okay? Let's read the question, then we're going to do a sketch. It says the vector A has magnitude 10 and makes an angle of 30 degrees with J. What does J mean again? Which axis? Y, the up. It means the up or the Y axis. The jump, good. And we're going to find A in I and J terms and in column vector format. Again, there's nothing new about the maths that you're going to do, but it's definitely a new way that these questions are being presented to you. So again, we're going to do a sketch. It's got a length of 10 and it's making an angle of 30 degrees with the up. So I'm going to start off with the up part here. And I'm going to do that it's got a length of 10 and this angle here is 30. I'm labeling that one 30 because it tells me it's making an angle of 30 degrees with J, which is the upward part. And we want to find out how much is this vector, how much is it moving across, and how much is it moving up. That's what the question is actually asking for us to find out. How much is it moving across, how much is it moving up? I'm going to label those two things, X and Y. What I'm then going to do is, I think this diagram is getting kind of confusing. It's still going to be SOHCAHTOA, but I don't want to have all these lines all over the place. So what I would do is I would draw another triangle and I would start ignoring some of that information. I'm not going to have that line anymore. I'm not going to have the arrow. I'm going to try and make it look more simple. I'm still going to keep my X and my Y, and I want to label some of the angles. Do we know what this angle down here is or this angle at the top here is? Yeah, we do. The top angle is 30. This one is 30. This one at the top is 30. And this one down here is 60. You only actually need one of the angles. So I'm only going to put in one of them. Okay, I'm only going to put in one of them here. I'm just going to put this one, which is 30. Again, this is SOHCAHTOA. First of all, I'm going to try and find out what X is. Which one did you say I'm going to use? Yeah, I've got the opposite and I've got the hypotenuse, so I'm going to use SO. So I get that the sine of 30 is equal to the opposite divided by the hypotenuse, that's X divided by 10. So X is 10 sine 30, which is, you probably won't know this yet because you haven't done trigonometry. Well, you should know this from GCSE actually. So we get 10 sine 30, which is just 5, okay? Sine 30 is a half. Yeah, that was in your GCSE. Obviously that's not gone so well, the memory of that. So we're now going to find out Y. Which one am I using out of SOH, CAT and TOA for Y? CAT, I've got the adjacent and the hypotenuse. So I get that the cos of 30 is equal to the opposite, sorry, the adjacent divided by the hypotenuse. So we get 10 cos 30 is Y. Cos 30, you should know what it's exactly as, root 3 over 2. But you get 5 root 3 for Y. Look at it, there's no new maths there. That's the same as what you'd have done in GCSE. There's nothing new about the maths, but your job is to know that you have to do a sketch and to think that you're allowed to use those other types of maths. Have we actually answered the question though? No, we now need to do what it wanted. It said, what is the vector A in I and J form? Well, in I form, 5 is the bit in the I direction, so it's 5I, underline the I, and the J part is 5 root 3J. It also wanted it in column form, so we're going to have it as 5 and 5 root 3. Lots and lots and lots of me talking there. I do apologise. I'm going to stop that recording and you're going to try those questions for me.